cos theta is given by the base, that is the length AQ, divided by hypotenuse, that is the length AP, right? But what is AQ? As you can see, AQ is the magnitude of the resultant velocity. So this is V. And what is AP? AP is the magnitude of the VB, the boatman's velocity, original velocity, right? So this is V by VB, and you can see from here the resultant velocity is coming out to be the boatman's velocity into cosine of the angle theta met by the boatman upstream with the direction of AB. This is the upstream direction against the current. The current is flowing, of course, in this direction here. So this is the upstream direction to the left, and to the right is downstream direction. So the boatman, if he makes an angle of theta while rowing with the line AB, in such case we can see that the resultant velocity is coming out to be the boatman's original speed multiplied by cosine of the angle made by him with the line AB. You can easily see here the value of V is coming out to be less than VB, because this is, you can see that the angle, yes, the angle between the VB and the VC vector is an obtuse angle. That is the reason, that's why it's happening. You can see VB, if you could just extend like that, this would be the angle between the VB and VC vector, and that's why in such case resultant V is coming out to be less than the value of VB. So this is V in terms of boatman's velocity and the angle of direction of the boatman's velocity as he tries to row his boat. Alternately, what you could do is that if you knew the value of VB and VC, you can easily apply the Pythagorean theorem and could write down that AP square, that is the hypotenuse square in the triangle APQ, is given by PQ square plus AQ square. And that means, putting the values, AP is of course the magnitude of VB. So VB square, PQ is the magnitude of VC, the current, water current speed, that is VC square, plus AQ. AQ once again, that the resultant velocity's magnitude, that's V square. So you can see from here what we are getting is this, that the resultant velocity's magnitude is coming out to be simply square root of VB square minus VC square. That's from Pythagorean theorem. So I could have two results here. First of all, I could express the resultant velocity's magnitude to be the boat's velocity or speed multiplied by cosine of the angle theta made by the boatman with the line AB in the upstream direction. Alternately, if I had the values of VB and VC, the magnitudes of boat's original velocity and the river current velocity, then I could express V also as square root of VB square minus VC square. Both forms will be helpful in doing problems. And lastly, I just want to introduce a figure here to make it even clearer. See, you are aware of vector resolution. So let's see what is happening exactly here. I'm just putting it. Just give me a moment. I just want to position my figure for a quick comparison. So here we go and position this figure of vector resolution by the side of VB. So you can understand that this was the velocity VB, say. Okay, if I just thought of VB itself and see how it could be broken down, this was VB and it made an angle of theta with the vertical AB in my figure. So if you could resolve this VB into two components, C is coming out to be VB cos theta, as you are aware by vector resolution. This is the component in the direction AB, and the other component parallel to the bank upstream is coming out to be VB sin theta, right? So the two components by resolution, that's the reversal of resultant finding. And you can see here this VB sin theta, that is along the bank in the upstream direction, is exactly anti-parallel to the VC vector. So this VB sin theta is actually cancelling out VC, because VC and VB sin theta, these two things, vectors, well, are equal in magnitude but opposite in direction. In such case, they would cancel each other out, and we're left with only VB cos theta, and that is the only velocity that takes the boat from A to B. So actually VB cos theta is nothing but V. So I'm just seeing the problem from a different point of view. Earlier I have seen VB plus VC giving me V, and now I just analyze that if I could break down VB into two components, VB cos and VB sin, then VB sin takes care of the ill effect, or I could say the effect of VC here by being exactly opposite to that, while VB cos theta takes the boat from A to B, the directly opposite point. Now this is the case of course, shortest route, because you cannot go from the other bank through any other path that is shorter than this. This is the directly opposite point B, bang opposite to the point A. But interestingly, as you can see, the time of travel from A to B, how much is that? This time of travel is obviously given by the length AB divided by V, not VB, it's just V, the resultant velocity. And since you have found out the value of V to be VB cos theta, and the length AB is of course taken to be D, this is coming out to be, the time of travel is coming out to be D by VB cos theta. Or I could even write down this is D, the width of the river, divided by square root of VB square minus VC square. Both are perfectly all right because I have two ways of writing down the velocity V here, either in this form in terms of the boatman speed and the angle of direction of motion of this boat, the way he's rowing the boat, how he's directing the boat, that angle theta with the upstream direction with AB, or you could alternatively express V as in terms of the magnitudes of the boat's velocity and the river current velocity, that is second one. Accordingly, the time of travel is coming out to be D by VB cos theta. Incidentally, this value is greater than D by VB. So thanks to the fact that the river current has to be taken care of, a part of VB is being lost in countering VC. So the time taken actually is not the shortest time, as we shall see very shortly from now. Let me highlight my results here.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.